In this lesson, we will evaluate determinants and use Kramer's rule to solve systems of 3 equations in 3 variables. First, let's learn how to evaluate the determinant of a 3 by 3 matrix. So here I've given you a 3 by 3 matrix, 3, 2, negative 4, 1, negative 2, 5, and 6, 1, 7. You remember when you use these vertical bars like this, kind of looks like absolute value bars. That is our notation for a determinant. So we want to find the determinant of this 3 by 3 matrix. Now, the way we're going to do this is by expanding by the minors. That's what the process is called. And what we want to do basically is choose any row or any column by which we will expand. Choose any row or any column. It does not matter which row or which column you choose to expand by. You and I will get the same determinant. You and I will find the same number. Okay, so I'm going to choose just, you know what? I'll choose the first column. I guess I'm choosing the first column because, if I were to choose the first row, there's a negative here. I may want to avoid that. So maybe the first column might be a good idea. But again, remember, you can choose any row or any column, okay? And this is what we're going to do. We are going to expand by the minors of the first column. So what that means is we're going to say 3 times the determinant of the 2 by 2 matrix found by eliminating the row and the column that contains 3. I'll say that again. 3 times the determinant of the 2 by 2 matrix found by eliminating the row and the column containing 3. So in other words, it will be, let me see here, equal to 3 times the determinant of the 2 by 2 matrix found by eliminating the row and the column containing 3. So it'll be the determinant of this 2 by 2 matrix, negative 2, 5, 1, 7. Next, it will be, let me undo this here. Oops. It will be 1 times, because 1 is the next entry in the column, it'll be 1 times the determinant of the 2 by 2 matrix found by eliminating the row and the column containing 1. So it'll be the determinant of this 2 by 2 matrix, 2, negative 4, 1, 7. Next, we will multiply by 6, because 6 is the last entry of this column. 6 times the determinant of the 2 by 2 matrix found by eliminating the row and the column containing 6. So it'll be the determinant of the 2 by 2 matrix, 2, negative 4, negative 2, 5. This is expanding by the minors. Now, one additional thing that we need is something called the array of signs. This is the array of signs, and the array of signs basically tells us whether we will be adding or subtracting these numbers. Okay, adding or subtracting basically these values that we're getting. Now, we chose to expand by the first column, did we not? This is what we expanded by. Therefore, we will be adding this first value. We will be subtracting the second value and then adding the third. Do you see that? Whether I'm adding or subtracting depends upon the array of signs, okay? So the array of signs will tell you the operations. Okay, so let's go for this. Let's evaluate. So this will be 3 times, remember it'll be AD minus BC. Here, I'll do this for us. It'll be AD minus BC, like that. Remember that kind of from an earlier lesson. So it'll be 3 times negative 2 times 7 minus 5 times 1. Then it'll be minus 1 times, now I'm here, okay? It'll be 2 times 7, 2 times 7 minus negative 4 times 1. We have to be super careful about our signs here. Negative 4 times 1. Plus 6 times, it'll be 2 times 5 minus negative 4 times negative 2. That was me evaluating the determinant of this 2 by 2 matrix. All right, so let's figure this out. So let me see if I can scroll this screen up a bit. And that might be good enough there. Let's see. So what do we have here? We got 3 times. All right, so we have negative 14 minus 5, so that's negative 19. Minus 1 times, what do we have here? 14, and then plus 4, so that's 18. And then we have plus 6 times, what do we have here? 10 minus, what is this? 84. 10 minus 84, so negative 74. Okay, like that. Oh, you know what? I noticed a mistake. Can we go back? And some of you probably noticed my mistake as well. When I evaluated this determinant here, I made a mistake. It's supposed to be 2 times 5 times negative 4 times negative 2. 2 times 5 minus negative 4 times negative 2. But when I wrote it out, I did 2 times 5 minus negative 4 times negative 21. I accidentally... You know what it is this parenthesis? It's a parenthesis, but I think I read it as a 1. So let's be very careful. Well, I need to be very careful, right? So this is a parenthesis. That's not the number. Let me erase that here. That's not the number 1. Okay? So in other words, here, where is it? Right here. This should be 10 minus 8. 10 minus 8. So this should be 2, not negative 74. So let me erase that. I'm glad I caught that. So 10 minus 8. So that should just be 2. All right? So now we have 3 times negative 19, which is negative 57. We'll get that up on the board. Negative 57. And then we have minus 18 plus 12. All of this, I believe, is negative 63. So this is our determinant. And we expanded by the first column, right? We would have gotten the same determinant regardless of which column or row we expanded by. Okay, cool. Let's look at another example that we can walk through together. All right, so we have a brand new 3 by 3 matrix. We want to find the determinant of this matrix. 2, 4, 0, negative 5, 2, negative 3, negative 4, 1, 0. Now, remember that we can expand by any row or any column. Now, which row or column do you think would be the easiest to expand by? I think it would be column 3. Do you know why? Because if we expand by column 3, there's a lot of zeros in column 3, which would greatly reduce the amount of work that we need to do. Again, you're free to choose any row, any column you want, but I highly recommend column 3 because it's going to cut down on your work. To be honest, whenever I see a 0, I will expand by the row or column that contains that 0 because it'll reduce the amount of work we have. Alrighty, okay, let's not forget the array of signs. We are expanding by the third column. So we'll be adding, subtracting, and then adding, okay? So here we go. So this will be equal to 0 times the 2 by 2 matrix found by eliminating the row. Let me see if I can do this for us. The row and the column containing 0. So therefore, it'll be -5, 2, -4, 1. According to the array of signs, we will be subtracting the next value. Ooh, watch your signs. Subtracting by the array of signs, right? By this sign here. And now we'll be talking about -3 times the 2 by 2 matrix found by eliminating the row and the column containing -3. So it'll be 2, 4, and then -4, 1. Okay? And then we have, according to the array of signs, we're adding the next number. It'll be 0 again, times the 2 by 2 matrix found, make that look like a 0. There we go. The 2 by 2 matrix found by eliminating the row and the column containing 0. So it'll be 2, 4, -5, 2. Okay, so this is what we have. This is where this is really beautiful, right? It's 0 times this determinant, which is just 0 because anything times 0 is 0. And then it'll be plus 3 times, remember this is 2 times 1 minus 4 times -4. 2 times 1 minus 4 times -4, like that. Plus 0 times this determinant, which is just 0, because 0 times anything is 0. See how you don't have anything to, any arithmetic to do here. You don't have any arithmetic to do here because you expanded by these zeros. Excuse me. So it is just then 3 times 2 plus 16. So that's 18. So then the determinant is 54. Again, choose to expand by the row or column that has a 0 or zeros in it. It'll reduce the amount of work we have to do. Now that we understand how to evaluate the determinant of a 3 by 3 matrix by expanding by the minors, we can now look at Cramer's rule. Specifically, Cramer's rule for solving a system of 3 linear equations in 3 variables. So here I've given you a system of 3 equations in 3 variables. The variables are x, y, and z. A sub 1, b sub 1, c sub 1 are the variable coefficients of the first equation. D sub 1 is the constant of the first equation. A sub 2, B sub 2, C sub 2 are the variable coefficients of the second equation. D sub 2 is the constant of the second equation. A sub 3, B sub 3, and C sub 3 are the variable coefficients of the third equation. And D sub 3 is the constant of the third equation. The solution is an ordered triple, x, comma, y, comma, z. It's the point at which these 3 planes intersect. Each of these equations in 3 variables defines a plane. So we want to find where these 3 planes intersect. They will intersect, if they intersect at all, they will intersect at a point of intersection, an ordered triple. X is found by taking the quotient of this determinant called d sub x by this determinant called d. Y is found by finding the quotient of these 2 determinants, d sub y and d. And z is found by finding the quotient of these 2 determinants, d sub z and d. So what I want to teach you now is how to find d, how to find d sub x, how to find d sub y, and how to find d sub z. So let me scroll down a little bit and tell you what each of these are. The determinant called d is the determinant of your variable coefficients. So it's basically the coefficient matrix. So it's A sub 1, B sub 1, C sub 1, A sub 2, B sub 2, C sub 2, A sub 3, B sub 3, C sub 3. Notice that these are all your variable coefficients. And some of these subscripts are pretty sloppy. Let me see if I can rewrite some of these, especially this last row. A sub 3, B sub 3, C sub 3. These are all of your variable coefficients. Furthermore, this first column is the column of your X variable coefficients. These are your Y variable coefficients, and these are the variable coefficients for variable Z. So this is the coefficient matrix, basically. Now, D sub X, watch this now, D sub X is exactly the same as D. The only difference is that your constants, your column of your constants will take the place of your X column. Because you're finding D sub X, we let the constants replace that X column. The rest is the same though. That's a 2 there. Oops. Let's see if I can make that better for us. B sub 2. C sub 1, C sub 2, and C sub 3. I guess I have an issue with writing 2's. There. So that's D sub X. So the same is true for D sub Y and D sub Z. D sub Y will be exactly the same as the determinant called D. The only difference is that your constants will now be written in the Y column. See, this is the same as determinant D, except your constants are now in the Y column. This is for finding D sub Y. Every time I write a 2, it seems like I'm struggling. C sub 2, C sub 3. So you can probably finish this off. D sub Z is this determinant where the constants will now be in the Z column. Okay? And the other columns are the same as determinant D. So this is Kramer's rule. So you can see it's basically all about expanding by the minors. It's all about evaluating the determinant of a 3x3 matrix. So now that we've written down Kramer's rule, let's actually use it to solve a system. All right, we have a system of 3 equations in 3 variables. 2x minus 3y plus z is equal to -1. 3x plus y minus 2z is equal to 9. Negative x plus 4y plus 2z is equal to -7. In order to find the ordered triple, x, y, z, we need 4 things. We need d sub x, d sub y, d sub z. So let's find each of these determinants now, all right? So let's find this determinant. Now this determinant called D is the determinant of your variable coefficients. So it's 2, -3, 1, 3, 1, -2, -1, 4, 2. Okay? Unfortunately, there are no zeros here that we can take advantage of, but it's okay. All right, remember we want to expand by any row or any column, completely up to you. I am going to choose, how about row 1? I will expand by row 1. Let's not forget the array of signs. We're choosing to expand by row 1. So we'll be adding, subtracting, and then adding. All right? Let's go for it now. So it'll be 2 times the 2 by 2 matrix found by eliminating the row and the column containing 2. So it'll be 1, negative 2, 4, 2. According to the array of signs, we'll be subtracting next, and we'll be subtracting negative 3 times the 2 by 2 matrix, the determinant of the 2 by 2 matrix, found by eliminating the row and column containing negative 3. So eliminating that column and that row gives you 3, negative 2, negative 1, 2. Very good. Now, it will be plus 1. Actually, let me write it down here because I'm running out of space there. Plus 1 times the determinant of the 2 by 2 matrix found by eliminating the row and column containing 1. So it'll give us 3, negative 2, 3, positive 1, negative 1, 4. That was found by eliminating the row and column containing 1. Okay? All right, cool. Let's evaluate. So let's see. We have equals, let's move the screen up. So it'll be 2 times 1 times 2 minus negative 2 times 4. Remember that it is AD minus BC. Next, it will be plus 3 times 3 times 2 minus negative 2 times negative 1. Be careful with all the signs, okay? Plus 1 times 3 times 4 minus 1 times negative 1. All right. A lot of arithmetic, right? So it'll be 2 times, and what do we have here? We have 2 plus 8. That's 10. Next, we have 3 times, let's see, we have 6. That's a negative sign right there. It looks like a decimal point, but it's a negative sign. So it is, just confirming here. Yeah, it's a negative sign. So it's 6 minus 2. That's 4. Plus 1 times, and what do we have here? We have 12 plus 1. 12 plus 1. 12 plus 1, 13. All right. So we have 20 plus 12 plus 13. And this is 45. Isn't it? Yes, 45 is this determinant called D. All right, cool. Now let's find D sub x. All right, this is D sub x here. I want to remind you how I got these entries. This first column is the column of your constants. This is the column of your y coefficients, and then your z coefficients. To be honest, these two columns here are the same as the previous two columns for evaluating D. This column got replaced with the constants because this is the x column. Okay, we have to choose a row or column to expand by. You know what, just to keep things, consistent, but you don't have to do this, but in order to keep things consistent, I'm going to expand by row 1. Now, let's not forget the array of signs. We'll be adding this value, subtracting this one, and then adding. Add, subtract, then add. All right, here we go. We're expanding by the minors along row 1. You may want to pause the video and get ahead of me a little bit, and then we can see if you and I have the same work. All right, expand by the first row, and let's see if you and I agree. So go ahead and pause the video here. All right, I hope you got this line of work here. So it's -1 times the determinant of this 2 by 2 matrix minus -3 times this determinant, and then +1 times this determinant. All right, if we agree, then go ahead and pause the video again and do all of this arithmetic, and let's see what you and I get. All right, I hope you pause the video and work this out for yourself. And let's see if you agree. I got 45 for d sub x. So d is 45 and d sub x is 45. Pretty cool. All right, let's move on to d sub y. Okay, d sub y will be the determinant of this 3 by 3 matrix, which is basically the same as capital D that we found earlier. The only difference is now your constants are in the second column, are in the y column. Okay, we have to choose a column or a row to expand by in order to keep things consistent. And again, you can do something different if you want. I'm going to expand by row 1 like I have been. I guess no particular reason, but just to remain consistent. The array of signs says we will be adding and then subtracting and then adding again. This would be a great point to pause the video, the lesson once again, and to work ahead of me and see if you're understanding this correctly. So go ahead and pause the video here, and then we'll meet up in just a few seconds. All right, pretty cool. Well, good work, you guys. I'm getting 0, and I hope you found 0 as well. All right, check your work, check my work, and hopefully you and I agree. Okay, let us now find d sub z, which is the last determinant you and I need to find. Okay, d sub z is the determinant of this 3 by 3 matrix. Again, this is exactly the same as capital D, right, that we found earlier. The only difference is now the constants are in the third column, or in the z column, okay? Constants are here. These are the variable coefficients for x. These are the variable coefficients for y. We have to choose a row or column to expand by. Again, choose any row, any column you want. It should not matter. Again, to be consistent, you probably guessed this a long time ago. I'm going to expand by the first row. The only reason is to be consistent with my earlier work. According to the array of signs, we'll be adding, subtracting, and then adding. All right. So again, this will be a great point at which you can pause the lesson. I hope you do that and work ahead of me, and then you can play the video again and then see if you and I have the same work. All right, good luck. Pause the video now. Okay, I hope this first line of work here matches yours. So it's 2 times this determinant. It'll be minus -3 times this determinant plus -1 times this determinant. Now it's time to evaluate each of these determinants here. Okay, just checking in with you each step of the way here. So I get -7 minus 36. I get -21 minus -9, which is +9. I get -1 times 12 minus -1, which is 12 plus 1. All right, folks, we did it. -135 is what we got. All right, here we go. Now we're ready to build or write down our final answer, right? So remember that x is d sub x over d. Now d sub x, you may need to refer to your notes, but we found that to be 45. We found d to be 45 as well, so x is 1. Y is this quotient, d sub y over d. Again, d is 45, right? And we found d sub y to be 0, so this coordinate is 0. And then z, we just found d sub z divided by d. We found d sub z to be -135. And again, d is 45. So then this coordinate here is -3. So the point at which these three coordinates, the point at which these three planes meet or intersect will be at these coordinates, 1, 0, -3. Isn't that cool? This is the final solution. Good work, everybody. Now you can solve systems of 3 linear equations and 3 variables using Kramer's rule.